Alright, so in this problem, I have x to the power of y minus y to the power of x is equal to 17. So, to solve this problem for my solution, I'm going to first, let me rewrite the equation right here. Now, to start, just by looking at this equation, what can we infer? Well, notice how we have x to the power of y minus something is equal to 17. And 17 is greater than 0, right? Meaning, x to the power of y is greater than y to the power of x. And this also must mean that x is greater than y, and y is greater than 0. So now that we know this, I'm going to rewrite my equation here. X to the power of y minus y to the power of x is equal to 17. And x to the power of y, I can rewrite this as x to the power of y to the power of 2 over 2, because 2 over 2 is the same thing as 1, and x to the power of y to the power of 1 is the same thing as x to the power of y. Now this I can rewrite as x to the power of y over 2 to the power of 2, because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n, so I can switch these up. Now, y to the power of x, I can also change this up as well. So y to the power of x, I can rewrite that as y to the power of x to the power of 2 over 2. And this, I can rewrite as y to the power of x over 2 to the power of 2. Now from here, remember my original equation was x to the power of y minus y to the power of x equals 17. Now I can replace x to the power of y with x to the power of y over 2 to the power of 2, and y to the power of x with y to the power of x over 2 to the power of 2. So now I get x to the power of y over 2 to the power of 2 minus y to the power of x over 2 to the power of 2 is equal to 17. Now I'm going to let x to the power of y over 2 equal to the variable a, and y to the power of x over 2 equal to the variable b. So now, if I substitute in a for x to the power of y over 2 and b for y to the power of x over 2, I get a squared minus b squared is equal to 17. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So a squared minus b squared, that's going to equal a plus b times a minus b is equal to 17. Now the only factors of 17 are 1 and 17, meaning that one of these two has to be 17 and the other one has to be 1. So just by looking at this, we can tell that a plus b is going to be 17 and a minus b is going to be 1, because a plus b is greater than a minus b. Meaning, I have two equations, a plus b equals 17 and a minus b is equal to 1. So now what I'm going to do is I'm going to add these two equations together. A plus a is 2a, b minus b is 0, so these two cancel out, and 17 plus 1 is 18. So I get 2 equals 18, and if I divide both sides by 2, I get a is equal to 9. Now I can plug back in a for 9 into my original equation. So we could just do either one. I'm going to do a plus b equals 17. If I plug in a for 9, I get 9 plus b equals 17, meaning b is equal to 8. So a equals 9, b equals 8. And we can even check it over here. Let's plug both of these in. A is 9 minus b is 8, and 9 plus 8 does equal 1. So now that we know a is 9 and b equals 8, we can go back here and notice how we let x to the power of y over 2 equal a and y to the power of x over 2 equal b. Meaning x to the power of y over 2 is equal to 9 and y to the power of x over 2 is equal to 8. So, to solve this, let's first start by solving the first equation. So x to the power of y over 2 equals 9. I can first start by taking the power of 2 on both sides. So then these two cancel out, and I get x to the power of y is equal to 81. Now 81, I can rewrite that as 3 to the power of 4. Now I'm going to do the same thing to y to the power of x over 2. I'm going to take the power of 2 on both sides, and then these two cancel out, so I get y to the power of x is equal to 64. Now 64, I can rewrite that as 4 to the power of 3. So I have x to the power of y equals 3 to the power of 4, and y to the power of x equals 4 to the power of 3. Well, what does that mean? Well, y 4 x 3, and over here y 4 x 3, meaning x is equal to 3 and y is equal to 4. So this is my solution to this equation. Alright, so in this video, I'm going to be solving the equation a to the power of 4 is equal to a minus 1 to the power of 4. So to solve this, my only variable in this equation is a, which is the variable I'm going to be solving for. And now for my solution, I'm going to first rewrite this problem down here so I have a little more solving space. So my problem is a to the power of 4 is equal to a minus 1 to the power of 4. Now from here, I'm going to subtract a minus 1 to the power of 4 on both sides. So then these two cancel out, and I get a to the power of 4 minus a minus 1 to the power of 4 is equal to 0. Now, from here, I'm going to rewrite a to the power of 4 as a to the power of 2 times 2. And I'm going to rewrite a minus 1 to the power of 4 as a minus 1 to the power of 2 times 2. And the reason I did this is because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So a to the power of 2 times 2, I can rewrite that as a to the power of 2 to the power of 2. And a minus 1 to the power of 2 times 2, I can do the same thing. I can rewrite this as a minus 1 to the power of 2 to the power of 2, and this is equal to 0. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So, in this case, I can think of x as a squared and y as a minus 1 squared. So by using this property, I get a squared minus a minus 1 squared times a squared plus a minus 1 squared. And this is all equal to 0. Now, we're going to go ahead and expand a minus 1 squared. So a minus 1 squared is the same thing as a minus 1 times a minus 1, which is equal to, I can distribute the a squared minus a. Now if I distribute the negative 1, minus a plus 1, which is equal to a squared minus 2a plus 1. So now I get a squared minus 2a plus 1 And then I have this times a squared plus a squared minus 2a plus 1 is equal to 0. Now for my left-hand side, these two cancel out, and all I'm left with is negative 2a plus 1. And for my right-hand side, these two add, a squared plus a squared, so I get 2a squared minus 2a plus 1, and this is equal to 0. So, now from here, what I'm going to do is divide this into two different equations. So my first equation is negative 2a plus 1 is equal to 0. And my second equation is 2a squared minus 2a plus 1 is equal to 0. Because either of these, just one of these needs to equal to 0 for the entire equation to be equal to 0. So now I'm going to solve each of these equations individually. For negative 2a plus 1 equals 0, all I have to do is add 2a on both sides, and I get 2a is equal to 1. Now, if I divide both sides by 2, these two cancel out, and I get a is equal to 1/2. So this is one solution for a. Now, for 2a squared minus 2a plus 1, what I'm going to be using to solve this is the quadratic formula, because this is a quadratic equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 2, b is negative 2, and c is 1. So I plug these values in, I get negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 2, times c, which is 1, all over 2a, so 2 times 2. And now this is equal to positive 2 plus or minus the square root of 4 minus 8 over 4, which is equal to 2 plus or minus the square root of negative 4 over 4. So now the square root of negative 4, I can rewrite that as the square root of 4 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I get a equals 2 plus or minus the square root of 4i over 4. And the square root of 4 is 2. So I get a equals 2 plus or minus 2i over 4, which simplifies to a equals 1 plus or minus I over 2. So this is another two solutions to my equation. And finally, just to check, I can't check the imaginary solutions, but I can check 1/2. So I have a to the power 4 is equal to a minus 1 to the power 4. A is 1/2, so I get 1/2 to the power 4 is equal to negative 1/2 to the power 4. And both of these equal 1 over 16. So this is right, and my solution is right.